Everyone, and thank you for having me. I am Sasha Romanenko, who is mainly a PHP developer from Zen framework background. Back in the day, I was a networking admin, so I configured Active Directories and such, so I have a bit of a bias about administration interfaces as a result of that. And also do JavaScript on the side, and unlike with PHP, you can hardly put a framework specialized in JavaScript. I'd like to say that I specialize in Next.js, but just as a math, I had to work with Dart, so it was all over the place. And today's focus is to work out how to make models on the front-end side of the application that coincide with the models that come from the server end. So I feel like sometimes as the front ends we don't really realize what it takes to have data structures that are compatible with the server layer, or we don't necessarily know what to ask the server guys, be it ourselves or our coworkers, what the payload should be like. And we tend to jump straight into outputting the payload alongside the HTML, and that creates lots of technical debt as we want to explore how. So for this demonstration, instead of slides, I decided to use the application in question as my own slides. So we are actually going to in real time debug my own presentation here. And all this is a Bootstrap default template. I got in right of the home page, slightly modified. We got a bit of a login form that whenever you press a sign in, doesn't matter what you put in, we have a list of issues. And the reason is everybody has the same issues, so it doesn't matter what you put in. Still a bit there. So everybody has the same issues, doesn't matter what you put in, you're going to get these things. So how does this application work so far? We have a typical Ajax request that calls up a URL, gets back the data, and creates an HTML string out of it. Now, fairly typical. One thing that we note is that we have a bunch of console logs, which somewhat imply that we're not really confident about what we're doing. So that's going to be one of the main themes. Whenever we see console log, that is an implication that we could potentially be doing something wrong because we have to continually re-examine what we're doing. So that shows that we don't really have a good structure to go on. So here we go. I'll create an HTML string, got a couple of if statements that decide what class to apply to the buttons. That's the buttons right here. And when we click on them, we have the main point of what I'm talking about appearing here. And this is a problem for a couple of reasons. Because one, when we look at this payload that's coming in, we don't really know what it is doing. We know we just have some kind of output coming from issues.json, which is, for the record, just a collection of my slides in a way. We don't really know how it applies to the application in question. We got a couple of fields, title, description. We can kind of guess what they are, but it's an oversimplified primitive example. Imagine big application and you're going to get lost. There is no placeholder pointers in that I have to continually be chasing the HTML object. So every time I create this string, it's going to be different. And I have to constantly requery it, figure out what my current structure is, using the inspection tools to figure out how to parse the JSON. And after that, we have an issue with inability to get the data. Because what I see a lot of clients do is once they run through the main callback loop from the Ajax request, because it's a callback, it's a challenge to save the data where you can later on ask, well, what is exactly the details of each of these boxes? Right? So we end up doing really awkward techniques where we requery the DOM for the data that we actually should have had already saved from the Ajax request, which is really unsafe. It's like, how are we expecting to not have any bugs by getting the information out of these things by querying what the inner HTML is? But I see that a lot, and it's quite sad. And finally, my greatest concern is these techniques that I come across don't apply to uploading the data back to the server. So without creating a concrete model, so you just parse the data as it comes in, you cannot guarantee that the data you are uploading back up is going to be in the same format. So you literally create two separate applications. You call it a single application, but in reality, when I look at it, it is two different pieces. There's one application for downloading the data into the browser, and the form to upload the data back might as well be a whole different project from the way I see it. So we're going to explore a way to combine that together. So my presentation style will be to actually see what it is. If I this monitor will let me, because apologies, the resolution for the monitor is slightly weird. It's not quite letting me. This monitor is troublesome. This one. Yeah, this monitor is not being incorporated today. Okay, so the first step in the first step in C is to see what is it that we can move out of the main title log. So the left side is where we were. The right side is where we're going to be going, right? And we got a bunch of files that we're going to adjust. The first thing that we see immediately different is the fact that we don't generate the string straight away. We request a thing called issue store. And so we have an issue store back here that has a convenient function that gives us all issues out of it. This issue store is going to be acting as a proxy for our Ajax request. So let's look at that. It's a brand new file at this point, so there's no divs. And the first thing to point out is that we can assign convenient properties of the URL that we're going to be querying. So if you have a separate store for every collection that you have, you can configure what the origins are. Right now, there's only one for get, and if your server has a single URL for both get, post, put, whatever, you can reuse it. Alternatively, you can say URL get, URL post, and this technique is taken straight out of ext.js. So part of the complaint about that framework is its learning curve is a bit steep, but if you understand this principle, then if you want to pick that framework up, it's pretty straightforward. This is the get all issues that we called from the catalog when we requested everything. So now we have an API access to our server. Right? So we don't call the server directly, we have this intermediate interaction that helps us to figure out how to get to the server. So we create these connection strings in this dataset layer, and you don't have to worry about them again. We'll come back to this in a little while later. The thing to note is, unfortunately, these requests are asynchronous. I mean, it's a good thing that it's asynchronous, but it makes our life a bit more difficult because you cannot return out of an asynchronous function. Right? So the best we can do is either continue a chain of promises, which is actually a really good technique in modern development. Alternatively, you can put a callback function as a parameter in here. So I would put maybe my catalog rendering thing. I would put this into a function, put that function pointer in here and then call the function to the success. But that's a bit old-fashioned. Promises is the future of asynchronous styles, so might as well get used to it. The idea is whenever either Jquery or just document native XML HTTP request finishes its task, it will move on to then automatically, followed by wherever is the done. It's there in the back, so I will get back to it. So there is the sequence for promises then, followed by done. Alternatively, you have an error, so you can display your models for things going wrong and so on. But the most interesting part in this code is the fact that we are creating an internal collection of all the issues that we're getting. So whenever output any of the issues that we get from the response directly, we parse them and always, absolutely always, put them in some kind of private variable. Now, what we actually put into those collections is the interesting part, and is pretty much the core of the subject today. If we look at the issue model, hence the title of the whole talk, this is what a typical model looks like. So, when we look at the original, when we look at the original traffic, let's refresh this real quick. This is what the traffic looks like, right? But there is no corresponding model with it. All we did up till now is to try to match these, but we haven't explicitly defined them. And now we are. Now at first you're going to say, well, it's a pain in the neck, all I'm doing is copy and pasting the property names. And you are, that's a good thing. It's one and only time when copy and pasting is good. All you really do here is take the payload from the server, copy and paste it into here. That's very valuable because you now don't have to chase the changes for these properties when your server gets updated. So if, for example, you need to query an extra column in the table, you don't have to chase your HTML DOM to try to match up the new properties with it. You do it all in one place. Alternatively, note how this is just a standalone, very primitive JavaScript object. That can actually go inside of your main HTML document, and you can generate it from your server. So at the same time you create a schema for your SQL tables, you can have it, if I did it in PHP, I would just echo this out in PHP inside of the main HTML page in JavaScript syntax. So when a page loads, it would actually get whatever the current version of that model is, without you having to constantly chase these properties around. It also helps you to do the validations and in environments where your payload response is not necessarily one-to-one what your front end is. So in a lot of real-world applications, you're going to get things like first name, last name, middle initials, but you don't necessarily care about the separations in the UI, so you can have a model that actually reflects what the user needs as opposed to what the server needs. And finally, we solved an issue of inconsistent creation. So because this is a separate object, we can now instantiate it not only in the Ajax responses, but also when we fill out forms. We can create an issue of this when our button clicks and pass it right back into, let's see, where is my review? We can pass it right back into here, and we can do a post request without any issues or accidents where our form keys don't match what the server keys are expecting, which is a very, very common problem. Finally, we also can filter out by certain things. So that's in the next section. And how you may ask, how do we get this out into the template? Well, JavaScript can override string methods. So note how up back in a catalog, one of the changes that we made is taking the issue that we're looking at and embedding it as it was a string. But issue is an object, isn't it? So how does JavaScript convert this to a nice string? Well, what we can do is if we override the prototype of that issues to a string, whenever we take a JavaScript object and put it into a context of a string, we can actually get back its template. So you can tell straight away where everything belongs now. So you don't have to chase your long chains or callbacks, as they're called, then figure out, well, what is this payload? Because again, one thing that I get from this is confidence that I know exactly what my structure is. So that's another reason for the copy and pasting here is good in payload, because you don't ever have to rely on console log anymore. You can just look at your structure and see exactly what you need in your template. So as we progress through this, we will notice that the amount of console logs is going to be less and less, and we can actually strategically place breakpoints better. So that's on object creation. We mentioned a point about how can we reuse those instances without having to chase DOM elements for additional data. So if we look at the next change log of get data from other sources, back over to the issue store we go, we can introduce a concept of indexing. So instead of just grabbing the data from the backend and losing it because it's an asynchronous callback, we should take the opportunity to index it in a way that is most useful or multiple ways. In this case, all I've done is indexed it using the IDs, but I could have done it based on titles, so I can do something like get particular issue out of this data set of issues based on a title. So the way that's done is whenever you receive the payload, just before you parse it and create an instance of it as just described, take the piece that you want out of it that you find important, that other parts of the application are going to find useful, and use that as a key for another private collection. Right? Because JavaScript is associative. You can emulate associative arrays using objects. So when you say ID index bracket whatever field you want to use as an index and assign to this pointer, you can now find any object that you want using any property type that you want. So we can see that later. When we now get any issue that we want by its ID, we check whether that issue has been queried before. If it has, we return it. Otherwise, we can go back to the server and see if such a thing exists. The huge advantage of this is when we go back to the catalog, we now don't have to chase the HTML DOM anymore. We have our instance of issue store. We get the issue by ID of whatever target was clicked on, and we simply get its description, which solves a lot of bugs that I see when I do my client calls. And as an added bonus, once we check this out, so now that we've seen a commit, we're going to actually find a listing again. So check it out here. So one last could you do accurate IntelliJ code completion when you do control space in JavaScript of all places. That usually doesn't happen unless you have a predictable structure that the IDE can follow. So The only time I had to do console log was to just make sure that the button that I'm clicking on is the one that I'm expecting. And after that, I'm 100% confident what I'm going to get, so less bugs for me. And now that we have checked that out, back to the browser we go. We refresh it, and everything should still look the same way. There. And what we can actually do, we can even inspect what our store currently contains. We can look at our indexes. So we have an index of issues by the IDs, or we can just in general inspect what is it that we collected. So my aim for this presentation is to make these techniques as available and realistic as possible. My suggestions that I made them from a perspective that if this wasn't after 8 o'clock in the evening, this is something that if you have an issue, you can go and implement it right now, because there is no need for introducing extra frameworks. Because one criticism I have of all the solutions that are floating around is, well, we have this legacy code, throw React at it, throw Dojo at it, throw XGS at it, and that calls for a rewrite. And these refactorings, they do not need a rewrite. All you do is you move your code a little bit around, you put your Ajax calls into a thing called data set. From the data set, you create instances of the actual model that is a copy-paste version of what comes in from the server that can optionally be automatically synchronized, and you're pretty much done. So the problem that some people have with this technique, as I do my client calls, is they find the structure of the issue a bit too cut and dry for them. This is very data-driven thinking, very object-driven, and to me this is fine. I would stop right here, and this would be the end of my presentation. If from experience I didn't know that a lot of people just don't think this way. Not necessarily a bad thing, everybody is wired in their own ways, and some people just have a mental block when they see objects of raw data, especially the JavaScript ones, where they're more used to templates and widgets and components. So the next section is going to present an alternative version of this model where we think about it from the widget perspective, but we still don't lose the flexibility of having a properly well-defined object. So please.
I have a question
Yes.
about your model. I'm finding that often I need two models, right? Like from the server and also for the presentation, and then some kind of mappr in between.
Yes.
When you're saving there, are you saving the server model and then have a function to kind of map to what you would want for the presentation?
Absolutely, yes. So at the moment, maybe you haven't picked the best of examples. That is more clear in the upcoming one. Now, to answer your question straight away, let's see where that mapping actually occurs. At the moment, the mapping is slightly primitive in that it is a one-to-one correspondence, but you can have the mapping as either part of the constructor. So this here acts literally as a constructor. You push the raw data into it, and it does the mappings between the raw server models and the front-end models. Alternatively, we can use setters, which is in the third section. And what you're talking about is the concept of a view model versus a model. So there's a design pattern, it's really horribly named. There is a thing called a model. There's a thing called a view. There's a thing called a view model. Three different concepts. So you are describing what a view model is, and we're going to be touching on that, which is that mapping of what a model that the server has and the model that the front end has. Is that accurate?
Yeah. Okay.
Right. So we're going to explore a more difficult version of the constructions. right around.
So traffic-wise from the server, it's great, you're just getting one thing. But is there any concern about storage on the client side? In a way, you're having everything double. Like, to me, it makes sense that I would do it, but I can see an argument that the client side starts bloating because you have a model that has all the information, you have your DOM that's repeating everything again.
So
a concern or not a concern, or it depends, I guess.
Not particularly, because most of those are pointers. So you have a model that will have a pointer to a string, and then your template is also a pointer to that. So the browser will actually do pointer arithmetic, really. It's not really going to do giant copies. Also, let's see what else is there. I hardly see the concern. I mean, the strings are just a couple of bytes at most. And if you're really concerned about optimization, if you load in 100-something records, which I did in my message broker, where I created a message broker application that was monitoring a real-time traffic going through RabbitMQ exchange. So that could be about 1,000-something of those objects come through at once. If you're concerned about that, then at the store level, you can simply be a bit more, well, not simply, not really simple here, you can be a bit more clever about your pagination styles. So if you are grabbing 10 objects, and you know you're going to use those 10 objects, just put only those 10 objects into this issue array, delete everybody else, and then the browser will do its garbage collection as long as you don't use those. So when you request your next 10, it will clean the previous up, and you will apply your pagination parameters to a URL so that the server will know to only grab exactly what the UI needs, so you don't have the extra duplication. So we got ourselves pretty much the answer that you were looking for earlier. What happens when we got a slightly more complicated mapping going on here? We have the same model of issue, and this time around we want to do a bit more difficult parsing. It's going to be incremental, it's going to be a more complicated example after, but for now what we have is a template that gets parsed, and on instantiation time of the object, we get the node pointers to the template. Okay? So where the template comes from is, let's see, mouse. Where does the template come from? The template comes from this here. It's a technique where the browser will ignore this tag, and it's just going to be there for you to query and get the basic outline of what the component should look like. You clone it. Right here, you're cloning it, and you're putting it into a temporary DOM element, and then you create private properties in that component or widget or model that specify exactly where in the template each particular DOM nodes are. So that will allow you to directly reference every DOM node in that component. So when we look at the, our template here, we can figure out exactly what this is. So this will be some kind of pointer in here. In this case, it's going to be a description node, a button node, or whatever. Now the next question is, well, now that we got the DOM nodes of the template collected and organized in this model, how are we going to map the models that are coming in from the data set? So if we switch over to the data set view, issues 2, and we see that it's not that much different all we're doing is mapping the model properties that are coming in from the Ajax request onto the properties of the model. But how does it know to connect this to a property? Because this is just like a basic assignment, it's an equal sign. Well, JavaScript has a thing called set interceptors. You don't have to use them, you can just use regular set as manually. You can just say object.set, bracket, parameter, and whatnot. You can do it manual way. But if we go back to the issue, that's what this syntax does. So if you don't use a regular function, colon function, with the name of the parameter, if you just put the word set in front of it, those are called set interceptors. There is equivalent version for get. C# folks will be very familiar with this. C# pretty much the whole language is based on this. For PHP build, this would be equivalent to magic getters and setters, pretty much. So that will do the mapping. So when your data store grabs your model from the server and applies it to the model, this is one place to do your mappings. What I do here is I have, again, a copy for the title, and then I apply it to the DOM. It's practically not a big memory issues. These are just strings. The only time it gets an issue is when your DOM gets too heavy. There is no performance penalty practically on the size of JavaScript object, but there is performance penalty on the size of your DOM elements. So what happened with the previous project that I worked on, when the rendering performance would slow down only when we talk about profile. And let's see, to do like a CPU profile then, let's do a little bit of it, and we just record this, and we stop it, and let's see, do we have a, timeline, so timeline is what I was looking for. So timeline, press record, do the sign in, do the stop record, where your performance always gets hit every time is in your green boxes. These are your renders. Okay. The JavaScript is negligible. It hardly even registers. What registers every single time is the paint events. That's what you really want to be looking out for. So that's a valid point, and I thought about those things too, and we got arguments with coworkers a lot until we look at hard data, and half the time we end up wasting time micro-optimizing what doesn't matter. We had an issue where we were loading real-time image data from for medical radiology. So these were full, giant, multi-megabyte raw image data that was uncompressed for the radiologist to be able to do actual medical diagnosis on you. So legally, we are not required to do any compression or modification of that image data at all. So those are massive, 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 massive objects in memory. And they did not even register in a profile. But what did was DOM creation. With the painting of these individual nodes. That's what you really want to attack when you deal with optimization, not the JavaScript mappings. So let's see, where is that in the changelog? So that's our issues here. One little side note, I use Jquery here. I did that intentionally just to show that it's good when you use it in a proper place. Jquery has its purpose, and that's very, very convenient DOM manipulation. So I could have done manual deep node cloning here, but it's really annoying to do manually. I could have just done it this way, or could have done Jquery element collection. So it's fine if you use it strictly for querying of DOM elements, but not application structure. And that's where I see lots of people do. They actually use jQuery for the entire application stuff, and that's really, really ugly to debug. And then it gets bad name for that. Like, oh, jQuery is this old, ugly thing, you shouldn't use it, use a proper framework. No, it's a good library for these little tiny utilities of querying and manipulating DOM, but don't use it for application architecture. That's pretty bad. Oh, and here's another case in hand about doing mappings with a priority, which is a value that will come from the server that's like high, medium, or low. But on the client side, it actually translates into the class name of is it going to be orange, green, or red. So that's another practical implementation of that mapping question. We go from the numerical or string priority to what it actually means for the client. And here we see just some application of the model to the DOM here. And as far as the catalog, the actual caller of it, the user of it, what's nice about this technique is now we don't have to deal with string manipulations. String manipulation is performance intensive, so if you constantly pass your strings, that is going to be a performance hit, because you have to parse it and inject it and manipulate it using whatever document object model the browser uses. If you use this technique, you don't have to go through the extra step. You create your DOM on the fly using the built-in DOM create elements, DOM subqueries, and whatnot. So at the end of the model creation time, you actually have a complete subroot. Once you have that subroot instance, you just append it, and you don't have to worry about string parsings and more memory leakage and more performance hits. So that takes care of that here. And again, now we don't have console logs at all, because we have straight through following of exactly what we expect. We can put a breakpoint anywhere if we really want to, but I know exactly what's coming out at every point. I don't have to guess anymore what I'm doing. So I'm saving a lot of time doing this because I'm really confident about what kind of data is at every line or every loop iteration. So that creating on the model side. Now, that concludes the JavaScript model parsing that's coming from the server. But I still get into arguments with developers sometimes where they think that models only belong to the server. There is no place on the front-end client side to do any kind of data. I think client side is just HTML, just JavaScript events, and what they do is they create templates on the server based on the server models, and they inject those templates directly into the HTML. So what I mean by that is if we go over to the fourth one, let's check that one out. So we kind of went back to where we were in the very beginning, where we're passing HTML directly. And where did my browser go? Oh great, my browser crashed. Excellent. Apologies, commercial break. Let's see. Browser get nervous. Okay, good. Are we good now? Okay, so the browser has recovered. It had its therapy session. So what we have here is somebody doing that. And this is something that I have lots of fights with other developers, where I think, again, modeling is not something to be done on the front end. Front end is just dumb output. I thought they were a bit strange. Why would they think about it? Until last year when I attended a Microsoft Build conference, they were doing a world tour around the globe. World tour around the globe. And I stopped by Toronto. It was a free session as well. And they had the website that would show the schedule. So when you go there, you can figure out what you want to do. And I was just curious to see how Microsoft does their front ends, because that's what you do. You visit the website and you don't really care about its content, but you instead care about how it's made. That's more important than what actually the site does. So I go into the Microsoft website and open up the console, that's what you do. And I noticed that even Microsoft does this. They pull down not fancy JavaScript objects to display their schedules. They actually do that. And I thought, well, I guess it's the same people that gave us Windows Millennium, so you can't really expect much better. I mean, maybe those folks got promoted into the web development world, and here we go. That page doesn't exist anymore, so the new version of the build conference doesn't do that anymore. So. But the point is, this is still a reality. This is still what people do. And half the time you don't really have a choice, either because it's already foreign, you got 50,000 lines of service spewing this out, or you just don't have control over it. Why is this a bad thing? I get asked a lot, why is this a bad thing? Why is it that the server can't just output a template and have it passed by the front end and be done with it? Well, this is what I sometimes see when I visit clients. Let's do this. This is something that I have seen. This is not a made-up example. And when we refresh this, let me get the big screen. Yeah, we'll have that. So what happens is when you do these HTML requests, the server has to be able to decide whether it's an HTTP request or an AJAX request. If you do any kind of Zen framework or Symfony, whatever frameworks that have a concept of context switch, where the framework for you will decide whether this URL came from a direct GET response or was it a background request. And there will be like a bunch of if statements that will let the controller on the server know whether it should, for that exact same URL, output a full HTML, or should it output a JSON object, or should it output an HTML partial, in this case the HTML partial. So what happens is, on bigger sites, the mistake that's been made is like the thing, well, again, front end is not a place to do logic, so I'm going to pre-random my templates. I'm going to use Twig on PHP, I'm going to use JSP for Java, and I'm going to render all my templates on the back end, and I'm going to push just that HTML partial when I get an AJAX request. And okay, fine, idea is good, works in theory, theory is fine. And then we have a thing called practice, where theory is over here, practice over here. When their site grows so big, they can't possibly keep track of all the URLs. So what inevitably happens is they forget to go to all the possible URLs the application can be accessed and put those if statements to look out for AJAX responses. So when the UI guy comes in, or even the same person comes in and does the AJAX request and forgets to do a context switch for that just one particular parameter, the response is actually an entire page being rendered on a server, sent in. The client doesn't know the difference. It's like, well, I'm supposed to render this HTML block, and the HTML block ends up being the entire website, so you have website within the website. And that was an interesting experience to see when I visited some of my clients as they struggled to read out all the individual parts of this was happening as opposed to creating a nice good models. So don't do that. All right, so let's see, how do we mitigate this? Again, we sometimes don't have control over what's happening. We don't have much of a choice. And sometimes you just have to scrape. Scraping is a thing that sometimes web developers have to do. So how do we scrape this without losing our wonderful model realm that we have established and everybody's going to do tomorrow morning? Well, we use our constructor mappings again. So let's do this. Apologies. Let's go. Oh, we did it this time. Okay. So move tablet string assembly to own class. No, that's an old one, is it? Scale. Yes, that one. So store. So before that, we saw how the store takes in the properties from the server and passes them into properties of the client. And again, that's also really useful when you have nested objects. This example only shows one level, but if you have multiple levels, so if you have an issue that points to a project, like if you're doing Jira, for example, when you pull down a Jira or any other issue, bug issue tracker, you get of the issue, you get the epic where it came from. If you do an agile style boards, you get overall project where it came from, and you can even do git commits, because the Jira is nice to be able to track all the code commits that you push against a particular issue. Really nice workflow. So that's an example of a nested structure that you can have, and that is easily created just by calling another instance of whatever, commit store, project store. You're going to have like a call to the project store over here, and you're just going to add a method on it, just like you would do a data map or an identity map. But in this case, we don't have that luxury. We don't have JSON objects coming in. We have an HTML content that we have to scrape. A very similar technique, we just think in terms of HTML. We put everything into a temporary DOM element. So don't ever put this straight into the DOM. Put it into a temporary, not like shadow DOM, but this intermediate thing. So in XML, there's a concept called document fragment. And I've done an XML here, but the point is you have your main document object model that has your general tree of your entire application, be it XML, HTML and browser, anything at all, just XML in general. And when you have the document object model object, you can create elements that are part of that overall DOM, but it's not part of the tree. So when you are done modifying this invisible branch, you can just swap a pointer to the branch in the main DOM, right? So basically, let me just do it here. Yeah, so you know how we have a root element in XML basically. We have that. We have items. We have item. You have your item and so on and so forth. So when you pass this, that creates your DOM tree. But you can have a sub-element that is underneath a section of memory called DOM fragment. So you manipulate it in here a little bit because you do want the convenience of DOM functions as opposed to weird and awkward string margins and regex, and who wants to deal with the regex when you parse HTML. You just do that. You do that in memory, and then because it's part of the same DOM instance, it's just a subsection of it, you can swap that fragment and point and change the pointer so it becomes part of the main tree, and then browser will notice that, hey, my DOM is updated, and will call a repaint, and all is good. So we take advantage of that right here in this div. So instead of going from, again, the data, we create a temporary create element. Notice that we don't attach this element anywhere. By doing it this way, without any assignments to the main DOM, we create a DOM fragment in that main structure. We apply the string that came in from the server, that nasty HTML that came in, and all of a sudden we have a really nice subtree that we can manipulate. We manipulate it by giving it to the issue, and let the issue deal with it again. This is just a data map. I shouldn't really be worried about the semantics of mappings. Over to the issues we go, and here we go with some fun. So before that, notice how we have on the left side, before we run into this issue, we collect the elements from the template. We clone the template so we can reuse it. Now we do the same thing, but we also need to get the defaults from somewhere, right? So we need to populate that model. How do we populate that model? by querying that subtree that we created in the data mapper or the data store. And that's happening right here. So you can query any DOM node as if it was the main document. And that's how you get your default data out of it. So instead of chasing your main page and worrying that your main site has changed their div structure because they're trying to get compatibility with i8, so they had to give it extra divs so that they can do better CSS manipulation. And so now you have all of these extra tags that you didn't expect coming in. So your data is the same, but it's just structured ever slightly so different. You have an opportunity to fix that right there, and it doesn't make the rest of the application. You query those modifications, you get them here, you assign them to the variables. Now, how does this, that looks like local variables, get propagated to the JavaScript object down here? And it's the same thing as before. As long as you keep in mind that JavaScript has 7 ways to instantiate an object. So listen, there are 7 ways. And one of the techniques that I really like, aside from the object literal, we saw object literal before where it was just a collection of properties in the curly brackets. We know that a function doubles as an object. So you can, if you call function directly, it does whatever the function does. But if you stop the word new in front of if you stop the word new in front of the word function, it magically becomes an object. So take advantage of that, call it an immediately executed object, so that when you create a new instance of this issue, there is a thing, the return statement, and you get back just a really nicely formatted collection of properties we had before. Okay? Yeah, you have a puzzle there?
Yeah, I didn't see what was at the bottom.
At the bottom, it's a return statement to the thing that we created, right?
Okay.
So we call, so over at the, see we have the word new. See, issue is a function. So if you just call issue directly, it would execute. But because we put the word new in front of something as a function, it's going to make an object out of it. Now, one way we can create private properties and don't expose all of this parse and mess and nonsense is by putting a return statement where we create an issue. And by putting a return statement here, we don't actually create an instance of the issue function, but we return an instance of whatever sub-object that we have created while the main constructor was running. So we're converting this function into a constructor thing that returns an object that we're actually looking for, and that object is the model that we had before. So, where am I? Right here. So notice that our catalog isn't even in a change log. We didn't even have to modify the application to adjust to this different model style because we had the proxy, the data map or whatever, take care of that for us. So that's how we fix the mess of having the Ajax written in HTML, but still having a control structure with all the benefits of being able to know let's see. Right. So we still have all the benefits of being able to directly query what we're doing. So we can still click on a button, we can still get this description, and when we update this instance, we can take this object and push it directly back into the post request to the server without any modifications. So let's see, was there anything else? So that does conclude the that does conclude the presentation. Thank you for watching.